All right, Erin. So I want to look at something else that logarithms are good for and really why they exist. And it's really about making predictions about either money or investments. A lot of times that's when we use logarithms, or they're used sometimes to predict when something will dissipate from the air. They have really all sorts of uses, really, just anything with time. Um, what I have right now on my computer is the logarithm calculator that I showed you about. I don't have a graphing calculator on me, but this is definitely a great tool, and it's really similar in your graphing calculator. When you get back to school, I'll show you how to use that. So here comes some of the uses of working with logarithms. So I want you to imagine for a moment that you decided that you were going to work for 2 summers. And in those 2 summers, you were going to work like every hour you possibly could. And you were going to save every penny, and you were going to just put it away in your life. And what happens is during these 2 summers, like you're working crazily, you were able to earn $5,000 each summer. So we're going to say that summer 1, you earned $5,000. And summer 2, you also earned $5,000. All right. And you decide, I'm not going to touch it. I'm also not going to put it into a savings account because you know that that's not going to earn any dollars. But you decide to research some really reputable companies. You find one and they say, hey, we're averaging returns of like 10.5%. So their returns are about 10.5%. And they compound their money every day. So they're doing daily compounding. And you're like, hey, that's pretty good, right? Like they're giving me 10.5%, or they're saying they're going to get about 10.5% in returns, and they're going to compound my money daily. And I know that's pretty good. I want to see whether this $10,000 investment will, in your lifetime, equal $1 million. Like, that's what I'm wondering in this problem. Will this $10,000 investment ever equal $1 million for doing nothing except for working those 2 summers? And I think you probably are getting the tone that it probably will, but let's see what will happen. We're going to set up an exponential equation for this first. So y is equal to, our initial investment is $10,000. We're getting a 10.5 interest rate, but it's being compounded daily. So I'm going to use that formula. Do you remember it? It's 1 plus my rate as a decimal. So I'm going to have to actually change this to a decimal. So 0.105 divided by the number of times I compound, which is 365. And then I'm going to raise that to the 365t. The number of times it compounds times the time. And I'm curious to see whether or not my output will ever be $1 million. So a 1 with 1, 2, 3, 4, 5, 6 zeros behind it. All right, so 10,000. I'm going to do a little bit of a rewrite on this. I'm going to actually keep this exactly as I see it. 1 plus 0.105 over 365 raised to 365t. Follow me so far? All right, so to solve this, I kind of have to balance. I need to divide out the 10,000 from both sides here. So divide this side by 10,000, divide this side by 10,000. We're going to have some eliminating zeros. So I'm getting 100. That basically means my output is 100 times the value I started with. Like, that's what I'm wondering. Will I ever get returns of 100 times what I began with? All right, so this this value, I'm going to break out the Google calculator. File, new window. Google, give me a calculator. Calculator. Oh, didn't spell that right, but Google knows. 1 plus 0.105 divided by 365 is equivalent to very small decimal. I'm going to include quite a few spaces here just so we can get a pretty accurate reading. So in this problem, I'm going to change this to 1.00028767. Notice how the next number is a 1. I think that's a good place to stop. Okay, so raised to the 365t. Okay, so what can a logarithm do for us at this moment? Well, a logarithm is going to solve for this exponent. So I can do a little bit of rearranging in this problem to rewrite it in logarithmic form. So how does that look? It's the log of whatever your base value is. So in this case, it's this huge decimal, 1.00028767. So log little, that number, of whatever I want it to equal, right? I want this to equal 100. And this is going to be equal to 365 times my time. So I need to evaluate this, and then I'm going to divide that value by 365. Okay? So I'm going to go back to my logarithm calculator. Don't know how many decimals it's going to allow me to put in here, but we're going to try 1.0002. This is actually harder than you expect. 28767 of 100. I'll hit calculate. Pretty big number, 16,000. So this is 16010.82. That's 16,000 equal to 365t. And then I just divide both sides by 365. Divide by 365. All right, Google calculator, you're up. So here comes Google calculator. I'm going to clear that out, and I'm going to type in 16,000 10.82 divided by 365. Let's see what we get out. 43.86. Okay, so I'm getting out a T of 43.87. All right, Erin, how old are you? So 16, or right? 16? So you're 16, we're saying you're going to work this summer at age 16, and you're going to work the next summer at age 17. You're not going to see any of that money. You're saving it away. So at the age of 17, let's do some math on this, right? At the age of 17 plus 43.87, 3 plus 7 is 0, carry the 1. 1, 2. At the age of 60, you would be a millionaire. And if you continue this trend along, like if you wait till 65, I wonder what would happen if we waited till 65. Well, we could actually put it into our equation and see what would happen. Or you can go into Desmos. So here comes my equation. Y equals, we're putting in a $10,000 investment. I'm going to put in the value exactly as I saw it. So plus point, so hold on 1 second. I just have to hit the division. So here we go. Plus 0.105 divided by 365. And then we're going to raise that to the 365. I'm going to give it an X on that. And if you notice, it's not appearing here. I'm going to change my window. So we're going to change this from 0 to, we're talking 43 years already here. So let's just project out till 65 years, right? And we're going to go 0 to, well, 1 million is what we knew we were going to get out. So let's even see what we could get into 2 million. So 2 with 6 zeros behind it. Did I do a good job? I think that looks good. All right, here's my graph. So I can look at, using Desmos, actually the intersection. So I could see at y equals 1 million. 1, 2, 3, 4. There's that intersection. That was the value we saw. 43.865 gave us 1 million. And I'm curious about maybe 2 million. Wonder if I'll ever get $2 million. Well, you're the one who worked those summers. Not in our time span here, but let's see. If we go a little bit further out, let's see what it was. 50 years. You might not want to wait that long, right? That's pretty late in your life, but not so bad. I mean, it's really only 6 or 7 more years until you get $2 million. Pretty nutty exponential equations. All right, so that's what a logarithm is, and that's how you can use a logarithm to be able to solve for time. So I hope that lesson found you well, and I look forward to seeing you in the next video.